Declared distances. Learning how to use and interpret declared distances data. The runway required for takeoff and landing of a jet transport airplane is an important calculation that every pilot must complete before or during a flight. An important element in this calculation is the knowledge of the usable length of runway available for the takeoff and for the landing operation. Therefore, it is important that pilots be aware of the concept of declared distances as a means of reporting usable runway lengths for takeoff and landing. Here we see a flight crew briefing the runway available for takeoff at the McCollum-Cobb County Airport near Atlanta. The runway at McCollum is 6,311 feet in length. However, the crew refers to the FAA Airport Facility Directory to see if declared distances have been published for this runway. Looking at the declared distances for runway 27, the crew notices that the takeoff run and the takeoff distance available are both 6,311 feet. However, the accelerate stop distance available is only 5,374 feet, a difference of over 937 feet. The pilot appropriately alerts his first officer to this fact to ensure no computation errors are made. Awareness of declared distances is key to ensuring accurate arrival and departure calculations. Declared distances refer to the length of runway declared usable for takeoff and landing for the purpose of airplane performance calculations. The accelerate stop distance available is the runway plus stopway length declared available and suitable for the acceleration and deceleration of an airplane aborting a takeoff. The accelerate stop distance available may be longer than the physical length of the runway when a stopway has been designated available by the airport operator, or it may be shorter than the physical length of the runway if the runway lacks an adequate runway safety area or in some other way does not meet runway design standards. Takeoff run available is the runway length declared available and suitable for the ground run of an airplane taking off. Takeoff run available is typically the physical length of the runway, but it may be shorter than the runway length if necessary to satisfy runway design standards. For example, the takeoff run available may be shorter than the runway length if a portion of the runway must be used to satisfy runway protection zone requirements. Takeoff distance available is the takeoff run available plus the length of any remaining runway or clearway beyond the far end of the takeoff run available. The takeoff distance available is the distance declared available for satisfying takeoff distance requirements for airplanes where the certification and operating rules and available performance data allow for the consideration of a clearway in takeoff performance computations. Landing distance available is the runway length declared available and suitable for a landing airplane. The landing distance available may be less than the physical length of the runway, or the length of the runway remaining beyond a displaced threshold if necessary to satisfy runway design standards. In most cases, a runway's declared distances equal the physical length of the runway, or in the case of the landing distance available, the length of a runway remaining beyond the displaced threshold. However, this is not always true with every runway. Runway design standards ensure adequate protection from obstacles, other airplanes, vehicle traffic, and undesirable activities surrounding the runway and in the immediate vicinity of the takeoff and landing path. In most cases, the environment surrounding the runway permits the full use of the runway for performance planning purposes. However, there are some runways that are geographically constrained, and a portion of the runway's usable length must be used to meet these design standards. For example, a runway safety area may extend into the usable portion of the runway, limiting the length of the runway that may be used for performance planning related to stopping the airplane, such as accelerate stop distance available and landing distance available. Let's look at how declared distances are used with takeoff and landing runway requirements for turbine-powered transport category airplanes. The accelerate stop distance is the distance required to accelerate to a point in the takeoff, then in response to an event take the first action to reject the takeoff at a speed no greater than v1 and to bring the airplane safely to a stop. Originally, the accelerate stop distance did not include consideration for events other than engine failure that could lead to a rejected takeoff. In 1978, the certification rules were amended to consider both engine failure and non-engine failure scenarios. Accelerate stop distance is now the longer of the distance with one engine failing just prior to V1, or with all engines operating throughout the rejected takeoff. In response to the disproportionate number of rejected takeoff accidents on wet runways, the certification rules were again amended in 1998. Manufacturers are now required to provide wet runway accelerate stop distance and wet runway takeoff distance data in the airplane flight manual for all newly type certificated transport airplanes, and the operating limitations for these airplanes require the use of this data when the runway is wet. The accelerate stop distance required for takeoff will be the longer of the dry runway accelerate stop distance or the wet runway accelerate stop distance. The calculated accelerate stop distance cannot be longer than the accelerate stop distance available. The takeoff distance is the distance from the start of the takeoff roll to the point at which the airplane attains a specified height above the takeoff surface. For a takeoff on a dry runway, the takeoff distance is the longer of the one engine inoperative takeoff distance to 35 feet above the takeoff surface, or 115% of the all engines operating takeoff distance to 35 feet above the takeoff surface. For airplane types certificated after 1998, when taking off from a wet runway, the takeoff distance will be the longer of the one engine inoperative takeoff distance to a height of 35 feet above the takeoff surface, if the runway is dry, or the one engine inoperative takeoff distance to a height of 15 feet above the takeoff surface, if the runway is wet. On a wet runway, the all engines operating takeoff distance is 115% of the distance to a height of 35 feet above the takeoff surface. The longer of the one engine inoperative takeoff distances for either a dry or wet runway, or 115% of the all engines operating takeoff distance to 35 feet, establishes the minimum takeoff distance when a runway is wet. The calculated takeoff distance cannot be longer than the takeoff distance available. The takeoff run distance is a consideration when the takeoff run available is less than the takeoff distance available. For example, when the runway has a designated clearway usable for takeoff planning, the takeoff distance available will be longer than the takeoff run available. The takeoff run is the longer of the distance required from the start of the takeoff to the midpoint between liftoff and the point at which the airplane attains a height of 35 feet above the takeoff surface, with one engine inoperative, or 115% of the distance required from the start of the takeoff to the midpoint between liftoff and the point at which the airplane attains a height of 35 feet above the takeoff surface, with all engines operating, whichever is longer. The takeoff run applies only on a dry runway. The calculated takeoff run cannot be longer than the takeoff run available. When taking off from a runway where the takeoff run available is equal to the takeoff distance available, the airplane's takeoff run may be considered to be equal to the airplane's takeoff distance. The landing distance demonstrated during certification is the distance required to come to a full stop from a point where the airplane is 50 feet above the runway. Air carrier, on-demand, and fractional operators must plan their flight such that their landing weight at the destination airport and the alternate airport, if one is required, will permit the landing distance demonstrated during certification to remain within 60% of the landing distance available. These operating rules impose a limitation on takeoff weight in consideration of the fuel used in flight. For eligible on-demand and fractional operators that meet certain qualifications, including the use of an approved destination airport analysis, this requirement is adjusted such that the landing distance demonstrated during certification must remain within 80% of the landing distance available. FAA guidance recommends that as close as practical to the time of arrival, flight crews perform an assessment of the actual landing distance required based on the reported weather and runway conditions, and include an additional 15% safety margin. The minimum runway required resulting from this assessment must be less than the landing distance available. The airplane operating rules and/or airplane operating limitations establish minimum distance requirements as well as weight limitations for takeoff and landing, and are based on performance data supplied in the airplane flight manual. The minimum distances required for takeoff and landing, obtained either in planning prior to takeoff or in performance assessments conducted at the time of landing, must fall within the applicable declared distances before the pilot can accept that runway for takeoff or landing. Declared distances are published in the FAA Airport Facility Directory for runways where they have been established. In the not-too-distant future, All Part 139 certificated airports, which are those airports with scheduled air carrier operations, will have declared distances published. In some instances, an airport may shorten declared distances for a runway when it is necessary to meet runway design standards. This is the case with Cobb County McCollum Airport near Atlanta, Georgia. However, there are many runways that do not have declared distances published. For runways without published declared distances, these distances may be assumed to be equal to the physical length of the runway. If the runway has a displaced threshold, then the landing distance available is assumed to be the runway length less the amount of the threshold displacement. Pilots who use U.S. government instrument approach charts and airport diagrams may recognize the inverse D graphic symbol. This symbol is also used to inform operators that there are declared distances established for one or more runways for this airport. The pilot should consult the FAA Airport Facility Directory to obtain these distances. Temporary partial runway closures, such as this example from Lubbock, Texas, may include a notice to airmen reporting revised distances. Pilots must be aware that the runway lengths stored in the navigation database of the GPS or flight management system may not reflect the runway's declared distance. The runway length at McCollum-Cobb County is 6,311 feet, which is the same value stored in the navigation database. Flight management systems for many business aircraft incorporate performance calculation functions. These functions can compute the takeoff and landing distances required for conditions and have the capability of calculating the maximum allowable takeoff or landing weight for a particular runway. However, these calculations are based on the runway information stored in the database. The runway length stored in the navigation database may not reflect a runway's declared distances, or the length of a runway remaining beyond a displaced threshold available for landing. For those flight management systems that do provide takeoff and landing performance calculations, the results of these calculations may not reflect the true maximum allowable takeoff and landing weight for that runway based on conditions. For example, the flight management system for this airplane calculates a maximum allowable takeoff weight of 38,247 pounds for takeoff on runway 27 if the runway is wet. However, the runway analysis for runway 27 reports a maximum allowable takeoff weight of 35,656 pounds, a difference of over 2,500 pounds. If the crew relies on the flight management system to compute their required takeoff field length, which in this example is 6,273 feet, they may not be warned that this value has exceeded one of the runway's declared distances. The 6,273-foot takeoff field length required exceeds the runway's accelerate stop distance available of 5,374 feet. The flight management system will provide no warning message of this exceedance. As you can see from this view, the Cobb County McCollum Airport's runway 27 has a physical length of 6,311 feet. However, both the declared accelerate stop distance and the landing distance available are 5,374 feet. This is 937 feet shorter than the physical runway length. There is no displaced threshold on runway 27, so some pilots may wonder why these distances are reduced. The last 937 feet of runway 27 is used to satisfy the requirement for a 1,000-foot runway safety area. The application of declared distances is intended to ensure that with respect to airplane performance capabilities only, the airplane has the capability of stopping during the landing maneuver or in the event of a rejected takeoff before intruding into the runway safety area. For this reason, the declared accelerate stop distance available and the landing distance available is less than the physical length of the runway. The takeoff data furnished for most business jets provides a minimum takeoff field length required based on takeoff weight, takeoff configuration, and environmental conditions. When the manufacturer provides takeoff performance data that shows only one minimum runway length, this length must not exceed the most restrictive of the takeoff declared distances of accelerate stop distance available, takeoff run available, or takeoff distance available. The minimum field length required for takeoff is usually based on the balanced field concept, which is a condition where the selected takeoff V1 speed results in accelerate stop distance being equal to the one engine inoperative takeoff distance. A small number of business jets are furnished with unbalanced field takeoff data that allows for the independent calculation of takeoff distance, takeoff run, and accelerate stop distance. These airplanes can realize a takeoff weight advantage over an airplane that is limited to balanced field takeoff data by calculating an unbalanced V1 that may be higher or lower than the balanced value, depending on the declared distances available. If the runway remaining beyond the end of the accelerate stop distance available is included in the takeoff run available and the takeoff distance available, then by using the unbalanced V1, this remaining runway may be used for calculating the takeoff run and takeoff distances to permit an increase in maximum allowable takeoff weight. However, the use of unbalanced takeoff data is an involved process. Use of an airplane performance planning software tool or an airport engineering service that furnishes a runway analysis is recommended. A number of business airplane operators use airport diagrams and instrument approach procedure charts furnished by a commercial provider, for example Jeppesen. On their charts, Jeppesen publishes usable runway lengths, not declared distances. The usable length concept was created many years prior to the formal creation of the declared distance concept and continues to be published on their charts in lieu of declared distances. Usable length takeoff is almost identical to takeoff run available, and usable length landing beyond threshold is similar to landing distance available, but they are not takeoff run available and landing distance available, and Jeppesen does not incorporate anything similar to accelerate stop distance available and takeoff distance available on these charts. When a takeoff value and/or landing value is available from source information that is shorter than the runway, Jeppesen wants to display the more conservative values. Jeppesen also publishes notes or otherwise explains length deficiencies or unique usable lengths. When the landing length is shorter than the full runway length, and this is not due to a displacement, then an additional explanatory ball note is applied, reading similar to the following: last 900 feet is unavailable for landing distance computations. A displacement is accounted for on the charts, not in a length value, but rather in a displaced threshold symbol designation on the charted runway. Jeppesen's charts are meant to be used for flight and navigation in the first place and flight planning in the second place. Jeppesen additionally offers other products and services specifically for flight planning. The full runway length will always be applied on the plan view to serve pilots' overall needs, as well as unplanned emergency decision-making. It is important to understand that the application of declared distances has no bearing on the operational use of the runway for taxi, takeoff, and landing rollout operations, provided the runway surface is appropriately marked as usable runway. For example, landing distance available for runway 9 must be used when showing compliance with the landing distance requirements specified in the operating rules or listed in the airplane's operating limitations, or when making a before landing performance assessment. The landing distance available is less than the physical runway length, not only because of the displaced threshold, but also because of the subtractions necessary to meet the runway safety area beyond the far end of the runway. However, during the actual landing operation, it is permissible for the airplane to roll beyond the unmarked end of the landing distance available. Likewise, the accelerate stop distance available for runway 9 must be used when showing compliance with the accelerate stop distance requirements of the airplane operating rules and/or airplane's operating limitations. The accelerate stop distance available is less than the physical length of the runway due to subtractions necessary to achieve the full runway safety area requirement. However, in the event of an aborted takeoff, it is permissible for the airplane to roll beyond the unmarked end of the accelerate stop distance available, as it is brought to a full stop on the remaining usable runway. In summary, it is perfectly acceptable to operate on any portion of a runway that is appropriately marked as usable runway, regardless of a runway's declared distances. These declared distances are for calculation of performance limits only.